Okay, stats. This is a review sheet that we filled out for chapter one. And I'm going to go through this all again because this is kind of important background behind statistics. So we're just going to kind of review this since it's been a while. But you will see this again in a college stats class, I'm sure. And this will kind of just help you know what some of the vocabulary is. So keep a hold of this sheet in case you have to take a college stats class, and this will help a lot. Right? So we're going to start. And we're going to do this top half, and then we'll do the bottom half in the next video. Okay, so I'll kind of split this up into two pieces. But they have the first thing that we talked about in chapter one was the difference between statistical significance versus practical significance. Okay, so something is statistically significant if less than 5% chance it will happen. Okay, so for example, if you have, let's say, 100 babies born, the chances of getting 98 girls in 100 babies that are born. Okay, so if 100 babies are just randomly born and we get 98 of them as being girls and only 2 of them as boys, the chances of that happening is going to be like 0.0000001%. Okay, so it has a less than 5% chance of happening. That is statistically significant. Okay, now practically significant, kind of one of the ways that I think about it is, even though it's less than a 5% chance of happening, am I going to pay a whole lot of money to do that? So I'm just going to say, is it worth it practically? Like, is it practical? Okay, so we might say 65 out of 100 girls born. Okay, 65 out of 100 girls born is probably still has less than 5% chance of happening. This would be like a 65 35 split, which the chances of that happening are probably pretty rare if you do because boys and girls should be closer to a 50-50 chance. So I would say that this split has a less than 5% chance of happening. Okay, less than 5% chance of happening. Okay, but if somebody would offer me a pill, right now because I'm pregnant, saying this pill will give you, 65 out of 100 times it gave them a boy, 35 out of 100 times it gave them a girl. Okay, less than 5% chance of that happening by chance. If they said that and gave me that split, I'm probably going to be like, well, how much does this thing cost? If this pill is going to cost me, $1,000 or a couple $1,000, 65 really isn't going to be a 65-35 split. There's still a pretty large chance that I'm going to have a girl. Not that I'm saying I want a boy at this point, but I'm just saying, like, if they would give us that scenario, less than 5% chance, yeah, that has a less than 5% chance of happening, but practically, am I going to spend the money on it? Probably not. Am I going to pay the money for this? No. Practically, it's not worth it to me. Okay. So parameter versus statistic, they have those two things going on. This was in section 1, 2. Parameters have to do with the population, and statistics refer to a sample. Okay, so we deal with statistics all the time, and we use them to make estimates about the parameters. Estimates. Okay, so we deal with sample statistics like the sample mean or the sample standard deviation. Okay, and that type of thing, those types of things will only give me rough estimates about what the population would be, okay? Now, I usually only deal with statistics because who wants to survey an entire population? Like if I want to do the entire population of the United States even, like that would take me forever to do. Plus, there's how many babies born every second. So I would have to accommodate them, plus the people that are dying at that instant. And it would just be kind of a weird, there's no way I could account for every single person. So it's really hard. So what I would do is just get a sample of those people and use that to make predictions or make estimates about a population. So population is parameter, statistic is sample, okay? All right, now, when we're given data, after we collect our data from our sample, okay, and come up with some statistics, we have either categorical or quantitative, okay? And then these four things fall underneath of descriptions of quantitative data. These two things fall under descriptions of categorical data. So this kind of division right here, these are all quantitative, these are all categorical, okay? So categorical is all categories. So these would be like names or labels, okay? So for example, you might have like, I don't know, classes. So I'll put class titles. Okay, so you might have like biology and statistics and algebra 2 and whatever those class titles are. You might also have like grade levels, or eye color. Those are all categories. Okay. Now, one more thing that I will add to this that we talked about when we did this section is categorical doesn't always necessarily mean that they are non-numbers, okay? So I could have like period 1, period 2, like for your class period, okay? So in that case, I do have period 1, period 2 as numbers, but they are considered categories, okay? So one thing that I'm going to put off to the side over here that says if it is a number, does it make sense to average? Okay, does it make sense to average it if it's a number? Okay, if not, it is a category. Okay, so it does not make sense for me to average period 1, period 2. Like we wouldn't say I'm in class period 2.75, right? That doesn't make any sense. So if it doesn't make sense to take the average, it's going to be a category. Okay, quantitative, these are all going to be numerical. Okay, so any numbers are going to fall under quantitative unless you have them as categories. There's no names or labels that will be over here. There might be some numbers in this categorical data, but there will never be any non-numbers in quantitative data, okay? So examples might be height, or temperature, or distance. Any of those would be quantitative data, okay, because we have them listed out as numbers, okay? Now, within quantitative data, we have discrete or continuous, okay? So discrete is countable. Okay, so I have a countable set of things. So when we're counting, we can count people, we can count pets, we can count, heaven forbid we would ever have to do this, we could count the stars in the sky. Okay, now a lot of people think stars in the sky would be continuous because the sky goes on forever, but there is a countable number of stars in the sky at this very point in time right now. I could count them if I wanted to. It would take me forever to do so, but I could count those stars in the sky. Continuous, a lot of times, is a decimal number that goes on forever. Okay, so for example, temperature. So I could round to the nearest whole degree. I could round to the nearest 0.1 degree or 0.01 degree or 0.001 degree, and I could keep extending that out, okay? So temperature, I could do that too. I could do height. So I could round to the nearest Foot, I could round to the nearest inch. I could round to the nearest centimeter, round to the nearest millimeter, round to the nearest whatever comes lower than millimeter. Okay, I could round to all of those decimal places out for height. Or distance. I could round to the nearest mile, round to the nearest foot, round to the nearest inch, centimeter, that type of thing again. Okay, so distances, all of those are continuous because I could have them as decimals that continue on forever. Okay, so a lot of people get those confused. Countable versus something that goes on forever. Okay, all right, so let's jump back over to nominal, ordinal. We'll go interval, ratio. Categorical data is going to either be nominal or ordinal. Okay, so nominal is just going to be names or labels that have no order. Labels with no order. Okay, names, labels with no order. Okay, so these would be like eye color, or maybe classes that you have that you're listing out. Okay, what else? Eye color, hair color. Let's see, grade level kind of does have an order, so I won't put that down. But anyway, having no order, like if I say eye color, they're, even though I would say brown eyes, is the better eye color because that's what I have. They don't really go in order, right? Like one is not better technically than the other ones, okay? Ordinal would mean they have a ranking. Have a rank. Okay, so examples would be, well, let's see what they did for ordinal. Ordinal, A, B, C, D, E, or A, B, C, D, or F for grades. Okay, so those are categorical data because you're getting labels on how well you perform. And there is a ranking system to how well you are doing. Okay, so that's an example of an ordinal, or them you putting them in order. Okay, numerical data is either interval or ratio after you found out that it's discrete or continuous. Okay, so interval would mean that you have no natural starting point. Okay, so no natural zero. Okay, so for example, you could have like years. So we are in the year 2020 right now, okay? But year 0 wasn't when time began because then we had, BC before that. There was no starting year 0. In addition to that, let's think of something else. Temperature. Temperature is a numerical or quantitative data, but temperature will go below 0. There's no natural starting point, even though there's technically an absolute 0, which we're not going to get into for science class, but temperature will go positive, negative. So the way that I think of an interval is that if you think of a number line, it goes in both directions, okay? So I have, that going on there. Ratio, though, does have a natural starting point, okay? Maybe not at 0, but it does have a natural starting place. So for ratio, we can think of like height. I'll put natural starting point, okay? So example would be height, okay? Because you can't have negative height, like here you could have negative temperature, but here you can't have negative height. Height really starts at 0 if you really want to go that far back into being like a baby that's just one cell, okay? Your height is technically like really tiny, so height is 0. There is a natural starting point there. Another example could be like time, like class time. So like you couldn't say, -5 minutes or something like that, right? So when you're in class, maybe you say you have 20 minutes to work on something or 10 minutes to work on something. Class times would start at 0 and it would go on for, as long as the class would last, okay? So another way of thinking about ratio versus interval. Let me write this off to the side over here. And then this will be the last thing. Ratio versus interval. The twice test. Okay. Does it make sense to say twice? Okay. Does it make sense to say something is twice as large as something else? Okay. Like for height, this person is twice as tall as this person. Okay. This class is lasting twice as long as another class. Okay. You wouldn't say that you wouldn't say that the year 2020 is twice as long as, the year 1010, because there was that many years before that. Okay. So that type of thing. So if it makes sense to say twice, ratio is going to be, the one that you use. So I'll put if yes equals ratio. Okay, that's what he is going to look like. All right. So that's just kind of the background of the first part of it. In the next video, we'll go through experiment, observation, and then the type of sampling methods, and we'll give kind of some examples of each one of those. Okay.